Good morning, dear sir. My name is Anmol Agarwal, and I'll be presenting Facade Design Pattern in my presentation as a digital assignment. So, in this PPT, I'll be explaining the intent, motivation, applicability, structure, participants, collaborations, consequences, implementation, and issues of this particular pattern. So, basically, there are three types of pattern, and Facade falls in the structural pattern category. So structural patterns in software design deals with the composition of classes and objects, providing ways to form larger structures from individual components. They focus on simplifying the relationships between these objects, ensuring that the system is organized and easy to manage. These patterns improve flexibility, efficiency, and maintainability in software systems by optimizing the relationships and interactions between components. Now, what is the intent? Like when we use the design pattern, what is the intent behind it to use? So the intent is providing a unified interface to set of interfaces in a subsystem. There will be several interfaces, and we'll provide a unified interface to all of them to show abstraction. Facade defines a high-level interface that makes the subsystem easier to use. The client will be accessing only 2 to 3 subsystems, which will be available, and rest will be hidden behind the Facade design pattern. Motivation behind this pattern. Systems are divided into subsystems to reduce complexity. A Facade provides a simplified interface to minimize communication between subsystems. Example, in a compiler subsystem, classes like scanner, parser, and program node handle low-level functionality. The compiler class acts as a Facade, offering a unified interface to simplify compilation. It hides complex details from users while still allowing access to low-level functionality for those who need. So the diagram looks like this. We can see here that we have several subsystems or interfaces which can be visible to client. But what Facade does is it hides most of these subclasses which are of less usage and show easier interfaces that can be used by the client. Applicability. A simple interface to a complex subsystem. As systems evolve, they become reusable but harder for most clients to use. A Facade offers a default, easy to use view for most clients. There are many dependencies between clients and implementation classes. A Facade helps decouple clients and subsystems, promoting independence and portability. The Facade design pattern provides the portability, that is, the code can be used from here and there. Like it can be copied from one place and used in other place. And it provides independence. You want to layer subsystems. The subsystems are layered behind the Facade design pattern. The Facade acts as an entry point. Like I said, there will be a Facade design pattern. 3, 4 client classes will be available, and rest all will be hidden behind the design pattern. Simplifying communication and dependencies between subsystems by making them interact solely through their facades. The structure of the facade design pattern will look like this. Now, the participants that are involved in this design pattern. A facade itself, the compiler, knows which subsystem classes are responsible for a request. Like when a request comes, it will assign which subsystem can do that or fulfill that request. Delegates client requests to appropriate subsystem objects. Subsystem classes, scanner, parser, program node, etc. Implement subsystem functionality. Handle work assigned by the facade object. Have no knowledge of the facade, that is, they keep no references to it. Collaborations. Clients communicate with the subsystem by sending requests to Facade, which forwards them to the appropriate subsystem objects. Although subsystem objects may perform the actual work, the Facade may have to work off on its own to translate its interface to subsystem interfaces. Clients that use the Facade don't have to access its subsystem objects directly. Consequences. It shields clients from subsystem components, thereby reducing the number of objects that clients deal with them, making it easy to use. It promotes weak coupling between the subsystem and its clients. It lets you vary the components of the subsystem without affecting clients. They can eliminate complex or circular dependencies. It doesn't prevent applications from using subsystem classes if they need to. Thus, you can choose between ease of use and generality. Implementation. Reducing client subsystem coupling. Make Facade an abstract class with concrete subclasses for different subsystem implementations, allowing clients to interact through the abstract interface without knowing which implementation is used. Public versus private subsystem classes. A subsystem, like a class, has both public and private interface. The public interface, including the Facade and other subsystem classes, is accessible to all the clients, while the private interface is reserved for subsystem extenders. The issues which are faced by the Facade design pattern. Oversimplification. Like all the subsystems are hidden behind the Facade design pattern, most of the complex issues which could be solved and used by the user are hidden. So it reduces the functionality, advanced functionality. The Facade may oversimplify the subsystem, limiting access to advanced functionality that some clients may need. Increased maintenance. As a Facade grows to handle more functionality, it can become bloated and harder to maintain. Changes in the subsystem might require updates to the Facade, increasing the maintenance effort. If you see the behind below the design pattern, the subclasses are very cluttered. So to add or delete any subsystem will require a lot of cost and time, which will increase the maintenance. Hiding inefficiencies. The Facade may hide inefficient interaction between the subsystems, leading to performance issues that are harder to diagnose. Any problem or any issue that would be harder to diagnose since it is very tree-like cluttered. Potential overhead. While decoupling clients from subsystem is beneficial, using a Facade adds an extra layer, which may introduce slight performance overhead. Tight coupling to Facade. If the Facade is too tightly coupled to a particular implementation, it could limit flexibility and make it harder to change the underlying subsystem without affecting the Facade. Limited extensibility. While the Facade simplifies interaction, it may limit extensibility if not designed with future changes in mind. So let's understand Facade design pattern with a simple analogy. The Facade is a TV remote. In this analogy, the remote control serves as the Facade. A TV remote provides a simple interface that allows you to perform a variety of operations, such as turning the TV on and off, changing the channel, adjusting the volume, switching between different input sources, that is HDMI, AV, HDMI port 2, etc. All of these actions seem straightforward to the user, but underneath the surface, each button press involves several complex operations which cannot be seen by us but are sensed towards the TV by IR. The subsystem, TV internals. Behind the scene, the TV consists of multiple complex subsystems responsible for various tasks. Example, display module, that is handling screen resolution, brightness, and color adjustments. Sound system, managing speaker output and volume levels. Input manager, controlling HDMI cables, AV input, USB connections, etc. Power system, regulating the power flow of different components. Each of these subsystems has its own integrated functionality, which is abstracted away from the user. The remote Facade simplifies access to these subsystems so the user doesn't need to deal with the complex directly. How Facade simplifies interaction. Without a remote control Facade, the user would have to physically interact with different buttons and switches on the TV to control various features. Imagine how cumbersome it would be to manually adjust settings on the display sound system and input sources every time you wanted to watch TV. The remote control Facade centralizes all these actions, allowing the user to control the TV without understanding or accessing the internal complexities of the subsystem. This mirrors how the Facade design pattern would work in software. It provides a simplified interface to a complex subsystem, making it easier for clients to interact with the system. Like just how you don't need to know what's the TV internal circuit work look like, users of a software system don't need to know this intricate working of the subsystem to perform high-level operations. Hiding complexity, users don't need to understand how the TV would work behind the subsystem. So that's been my presentation. Thank you so much, sir. My name is Anmol Agarwal and my registration number is 22MIS0174. Thank you.